Assalamualaikum and hi. My name is Nurin Irina binti Muhammad Safwan, taking a science diploma from group A4 AS 120120. Today I'm going to present my slide, which is chemical formula. Chemical formula was divided into two different formulas. One of them is empirical formula, the second one is molecular formula. First and foremost, I'm going to describe to you about the molecular formula. Molecular formula was known as the most regular formula, which is it's not a simplest formula like empirical formula. What I mean is, first and foremost, I'm going to describe to you about the molecular formula. Molecular formula was known as the second chemical formula is empirical formula. Empirical formula is a chemical formula that will give us the simplest mole number ratio of atoms in one compound. Empirical formula can be obtained by observing or conducting experiment. Empirical formula can be obtained by calculating mass of each of the elements. If the question is given percent composition, we don't need to calculate anything, just need to convert it into grams. The second step is calculate the moles of each of the elements using mole formula. And the third one, after we got the mole for each of the elements, we need to divide it with the most smallest value mole that we got in step 2. This is an example, one of the examples. From the question, we already know the mass for carbon and hydrogen, which is carbon 0.36 gram and hydrogen 0.06 gram. And refer to periodic table, we can get the relative molar mass for carbon, which is 12, and hydrogen 1. So just follow the step. First, mass of element, we already got it in the question. And then find the mole of each of the element, which is carbon, we got 0.03 mole of carbon, and hydrogen, we got 0.06 mole of hydrogen. The third step is find the mole ratio, which is divide each mole of the element with the most smallest mole value that we got, which is 0.03. So 0.03 divide with 0.03, we got 1, and hydrogen, we got 2. So in conclusion, the empirical formula for hydrocarbon is CH2. And then how to calculate molecular formula. In order to get the molecular formula, we need to calculate the empirical formula first, and then calculate molar mass for the empirical formula. The second step, divide molecular formula molar mass, which was given in the question, of course, with the empirical molar mass. And the third step, lastly, multiply the result with the suitable number. This is an example for molecular formula. So we already got empirical formula for hydrocarbon, which is CH2, and then the molecular molar mass for hydrocarbon already given in the question, 26 gram per mole. So just follow the step, find the molar mass for empirical formula, 14 gram per mole. And then second step, just divide 26 gram per mole with 40 gram per mole, and we get 1.8 or 2. Finally, just multiply C1 with 2 and H2 with 2. In combustion reaction, we already know that the meaning behind of the combustion is when an organic compound will be burned with an oxygen to provide carbon dioxide and H2O. So when carbon in the organic compound was burned with oxygen, the carbon will be converted into carbon dioxide. And then the hydrogen in the organic compound will be burned with an oxygen to provide H2O, which is water. So this is an example question I have provided in this slide. The question already gave us the mass carbon dioxide, which is 15.3 grams, and mass H2O, which is 26.4 grams. First of all, how to determine the empirical formula for combustion reaction? First of all, we need to find moles of carbon and hydrogen. For carbon, 15.3 grams carbon dioxide, which is mass for carbon dioxide, will be multiplied with 1 mole carbon dioxide divided with molar mass of carbon dioxide, and then it will be multiplied with 1 mole carbon divided with 1 mole carbon dioxide. So the answer will be 1.1 mole of carbon. For hydrogen, the mass of hydrogen, which is 26.4 gram, will be multiplied with 1 mole H2O divided with molar mass of H2O, and then it will be multiplied with 2 mole of hydrogen divided with 1 mole of H2O. So the answer will be 1.6 mole of hydrogen. After we got the mole value for each of the element, which is carbon and hydrogen, we need to divide it with the smallest mole value, which is 1.1. So for carbon, divide 1.1 with 1.1, we will get 1. And then hydrogen, we got mole for hydrogen, which is 1.6 mole, and it will be divided with the smallest mole value, which is 1.1, and we will get the answer 1.5. And lastly, we will multiply the result. In this slide, I multiply C1H1.5. I will multiply it with number 2, which is the answer I will get C2H3.